This is a short video that I will add to the end of my tutorial. The written description of the tutorial gives the justification for creating a robust model. But this video will just demonstrate pretty much how to create design tables and then checking those configurations that are automatically created from the use of the design table. So hopefully you can be able to get your model to this point of using this geometry here. The description there for this theoretical part is given in the handwritten portion of my tutorial. And you can get it to this point. And you can turn these annotations on here. When you turn yours on, under annotations show feature dimensions, you'll probably get a whole lot other annotations on there. If I say show, all of the features will have their annotations. I've gone through and right-clicked and hidden them, so I only show just the dimensions that I want to place in my design table and be able to change using configurations. So you can toggle those on and off if they're turned on. So you show the dimensions. I can select them individually and turn them off, or on that feature, I can right-click and say whichever one it was, show all dimensions. I can turn them off individually here, hide each dimension that I don't need to show. So we have just the 3 dimensions on there that we're going to use in our design table. So once I have those dimensions easily discernible, I can then go to Insert, Tables, Design Table, and I'll auto-create, leave these as they're checked, and say OK. And I'm going to then double-click on each of the dimensions here. I'll click them in order. I've got A, so I'll double-click on that one. That places it in the first column. B is the depth, and then C is the width. So I'll double-click on that dimension. And then I'm going to place a name on that first row and call it config 1. And on this one, we'll place it as config 2. And the next row down, we'll say config 3. And I'm going to change these values here. Let's say this one's 65, 55, and 105. And we'll say 67, 57, and 107. And we'll pick out here to the side, just in the graphics window, and it creates those 3 configurations. Now, if your dimensions aren't showing the name here properly, notice that when you click on a dimension, you can change the name right here when it's selected in the primary value. Put whatever name you want in there for the width. The default will probably be D1 or something of that sort, but you can pick on the dimension and change the name here so it's a meaningful name on the dimension. If the names themselves aren't showing, you can go to let's see, View, let's hide show dimension names. When that one's clicked on, you can see that the dimension names themselves aren't shown. So anyway, we've now created our design table, and notice if I go over here to configurations, it's automatically created these configurations. Now, default and config 1 should be the same thing. And config 2 and config 3, I think default was the same as config 1. Yeah, looks like those are up to. So it can change to those values, and they reflect the dimensions that I placed in my design table. So let's check our mass properties on this. If we make sure that our, if I go to the material thing, make sure this is set to copper, we can then compare our mass properties to make sure that we're getting the same values. I'm going to go ahead and edit that design table, and we'll come up here, expand the tables, say edit the table, not edit feature, but edit the table. And we'll change number 3. Let's say this one is 70, and this one's 60, and 110. And then click out here. And those are the 3 configurations that I've thought we could compare in our list to make sure that we're getting the same values. Now, the other requirement is that the origin needs to be back here in this corner. If you used a different origin to create your model, then you can create a new coordinate system by saying insert reference geometry coordinate system, and your origin is here. Your x-axis would be along this direction, and the y and z are in that orientation there. You can pick the others if you want. So now I have a coordinate system 1 and 2, which is the same thing in my model here. Obviously, I can put my coordinate system anywhere on this model. So let's check our mass properties. We'll go to evaluate mass properties, and I'm going to check that coordinate system that I just created and recalculate. And notice that my mass 22, oh, let's see, we're in config 3. Let's go to config 1 first. Let's check that one. So configuration 1, and evaluate mass properties, and make sure my coordinate system is correct, recalculate. So there's the mass, 1280.33 grams, and there are my coordinates of my centroid, or the center of mass. 3D centroid, so the mass will be the same point in this case. It's a homogeneous material throughout, so it'll be the same value. Let's check number 2. Question number 2, mass properties, and again, double check, make sure. This would be all the same in my case here because my origin and my coordinate system origin is all here in the same place. I get a mass of 1662.17, and there's my center of mass coordinates. And configuration 3, double click on configuration 3, mass properties. Mass is 2201.32, and those are cubic millimeters. Might want to change that to centimeters if you wanted in the volume. But anyway, then my center of mass 61.63, 30.55, and 31.55 is the center of mass. So hopefully that is helpful.